Okay, so within the quadratic formula, the portion underneath the square root symbol is called the discriminant. The part underneath the square root symbol is b squared, and I'm going to put it in parentheses like we did in our formula, minus 4ac. Okay, that is, if you look inside our formula, that is just this portion right here. The numbers underneath the square root, but not including the square root. So what that part is, it is called the discriminant. Oops, sorry. Okay. So if the discriminant is a number that is greater than 0, then what that tells us is it has two real solutions. Therefore, it has two x-intercepts. So what the graph would look like, and it can open up or down, but it would have two places that it crosses the x-axis. So if the discriminant equals 0, meaning the number under the square root is 0, then it has one real solution, which means it has one x-intercept. So what that would look like is if it has exactly one x-intercept, that means the vertex is on the x-axis, and then it either opens up or down. But just the vertex is on there. And then if the discriminant is less than 0, meaning a negative number, then it has no real solutions, which means it has 0 x-intercepts. So it can open up or down, but it will not cross the x-axis. So even if you extended this one on forever, it would not cross the x-axis. So this does not want us to solve. This says determine how many solutions there are. So it has to be in standard form where it equals 0. This is in standard form. So our a value is 1, our b is 8, and our c is -3. So you don't do the whole quadratic formula. You just do the discriminant, the b squared minus 4ac. So we have 8 squared minus 4 times a times c. And we type that into a calculator, and we get 76. So since that number is positive, it has two real solutions. Okay, let's try another one. So on B, it's not ready to solve quite yet because it is not in standard form and it does not equal 0. So first we have to subtract the 6x back to this side. Okay, we have 9x squared minus 6x plus 1 equals 0. Now we can do the discriminant, which is b squared minus 4ac. So b is -6 squared minus 4 times 9 times 1. And we can put that in our calculator and we get 0. If the discriminant equals 0, this is on our chart up here, when the discriminant equals 0, it has one real solution. All right, let's skip down and do D real quick. So we also need to move this into standard form. So I'm going to add the 4 because it must be equal to 0. So I have x squared minus x plus 4 equals 0. So now do our discriminant. It was b is -1 squared minus 4, a is 1, c is 4. So we can plug that into a calculator and we get -15. And when the discriminant is negative, think of square rooting a negative. It gives us no real solutions, so therefore it has no x-intercepts. Okay, so this is just kind of what I was alluding to here. It says find the number of x-intercepts of the graph. Okay, well, so it's already y equals or f of x equals is fine. And so it's in standard form. So you are literally just going to jump right in. You're going to do b squared minus 4, a is 2, c is 9. Type in a calculator, you get -63. When the discriminant is negative, you have no real solutions, which means you have 0 x-intercepts. The graph will not cross the x-axis is what that means. All right, let's try another one. So let's go ahead and skip down and do C. So it's f of x equals, same thing, totally okay, it's in standard form. So we're going to do b squared minus 4, a is 1, C is 36. So we type that in a calculator and we get 0. So when the discriminant is 0, think about when you square root a 0, there's only one solution. So that means there's only one x-intercept. And let's look at D, because if you look at D, it just looks a little funky. It is in standard form. So remember, standard form is ax squared plus bx plus c. So in front of x squared, this is a 1, so the a is 1. In front of x is a negative 1, so the b is negative 1. And c is missing, that means c is 0. So now we can go ahead and do b squared minus 4 times a times c. And what we end up with 1, and since the discriminant is positive, there will be two solutions, which means there will be two x-intercepts.